Welcome to Arxflix. Today, we're diving into the groundbreaking research paper, wav2vec, a framework for self-supervised learning of speech representations. This work showcases that learning representations from raw speech audio, followed by fine-tuning on transcribed speech, can outperform the best semi-supervised methods. Here's a visual of the wav2vec framework, illustrating how it jointly learns contextualized speech representations and an inventory of discretized speech units. Let's break down the main highlights of this paper. The paper introduces a self-supervised learning paradigm to learn data representations from unlabeled examples and then fine-tune the model on labeled data. This approach, already successful in NLP and computer vision, is now applied to raw audio data. In wav2vec, raw speech is encoded via a multi-layer convolutional neural network. This network creates latent speech representations, which are then masked similarly to masked language modeling in NLP. These representations are processed by a transformer network, which builds contextualized speech representations. wav2vec is unique in combining a contrastive task with a quantization of latent representations. The contrastive task requires distinguishing true latents from distractors. The training objective minimizes a contrastive loss math call alongside a diversity loss math call, to ensure broad use of the quantized representations. The feature encoder consists of several convolutional blocks. These blocks handle the raw audio input and produce latent representations, which are then fed to a transformer network to create contextualized representations. The model also includes a quantization module using product quantization and Gumbel softmax to discretize the encoder output. This enables fully differentiable selection of quantized representations. This equation captures the probability of selecting a codebook entry during quantization. In pre-training, wav2vec masks a portion of the latent output and solves a contrastive task. Fine-tuning involves training the model on labeled data with a connectionist temporal classification (CTC) loss. Experiments use the Libre speech dataset in both high and low resource settings. When using just 10 minutes of labeled data, the model achieves impressive WRs of 4.88.2 on clean other test sets. This framework achieves significant improvements over previous state-of-the-art models, even with very limited labeled data. Here's the contrastive loss equation, showcasing the importance of cosine similarity in training the model to identify true latent speech representations. wav2vec sets a new state-of-the-art for low-resourced speech recognition. With only 10 minutes of labeled data, it substantially reduces word error rates compared to previous models by about 1/3. Moreover, the framework is simple: pre-training on unlabeled data and fine-tuning on labeled data, significantly reducing the need for extensive labeled datasets. Finally, wav2vec achieves remarkable results on the full Libre speech benchmark, outperforming previous methods with weaker baseline architectures. This advancement can democratize speech recognition technology, making it accessible for more languages and dialects with very limited labeled data. To summarize, wav2vec represents a significant leap forward in speech recognition. This self-supervised framework excels with minimal labeled data and sets new benchmarks for the field. If you're interested in understanding the details, check out the paper and the code available on GitHub. Thanks for watching, and don't forget to like and subscribe for more summaries of cutting-edge research. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.